tiny web channel.
Exactly. Yeah. This is just for. All right. Welcome, Santana. I'm so happy to. Well, actually, I wasn't sure if I should join you because like the stakes are really high and you may fuck it up, and I don't want to be publicly seen uh, getting completely destroyed. No, I have all confidence in you, Santana. So excited about what we're going to try today.
So to give some context, last time that I did like a stream coding and everything, it failed, but it failed big time because it failed not just the what I was building, but the backup that I had. So everything failed, and it was because I don't know, but it was a pretty silly mistake. But anyway,
I have been with you in a few demos where you did the unexpected, but somehow we prevailed. So I have all the confidence in you, Santana.
okay, so let's start. So this is a little bit. I'm going to show a little bit how to ingest 1 billion rows per second. I mean, the main point is not to ingest 1 billion rows per second because it's pretty silly thing to do, to be honest, because ingesting 1 billion rows per second is easy, and we are going to see it. But I mean, what do you do with 1 billion rows per second? In one day you have so much data that is totally impossible to manage that. So we are going to go through the whole process on how to set up the whole cluster, trying to understand a little bit how ClickHouse works and everything, see the problems, and then we will analyze a little bit how we think Tesla is doing. I'm mentioning Tesla because this is from where everything starts, because everything starts with a talk from these guys. They put a talk that is pretty good. I recommend you to take a look. So it's a pretty good talk. So these guys explain how they created the whole ingestion system. To push 1 billion rows per second during, I think that it was a week or a few days, which is a pretty interesting challenge, because pushing 1 billion rows per second is easy. Doing that for weeks or days or even hours is super hard. I mean, and super expensive, I guess. I mean, I don't have any info on how much they spent, but I guess that was a lot. Anyway, I prepare a little bit of some kind of, let's say, slides. It's a markdown document, but before start, I just want to give like a warning. You can read it, but basically everything that we say here about ClickHouse is registered trademark by ClickHouse Inc. So everything that we talk about here, every time that I mention ClickHouse, remember that this is about ClickHouse and it's owned by ClickHouse Inc. We are always going to use the ClickHouse, the open source version. I don't know if it's community version. I don't know how they call it, but the open source version that is available for everyone. And that's it. Just this is for the ClickHouse lawyers mainly. If I make a mistake, sorry guys, I didn't mean it. I will fix it if I do it. Okay. Anyway, let's jump into the thing. So the idea, my idea is to start a little bit explaining. I already explained this intro, which is what is this about? It's like a challenge that we created. It's not a challenge, actually. It's like a kind of we were discussing, Sancha and I, in New York. We said, these guys, how is possible? I mean, I think that it's impossible to push 1 billion rows a second. And
sorry about my. Like every time I do something live, someone rings the bell. It's a tradition, so I'm expecting to have it in every live session that we do. Sorry, go ahead.
Yeah, so we were discussing about 1 billion rows a second. I think that that's impossible, and I said maybe it's not that impossible if you think about it. So that's why we said, okay, let's do it just to understand how it works. Actually, we said can we ingest 1 billion rows per second with the TinyBear architecture? Because, you know, at TinyBear, we use a really particular setup for ClickHouse, and we wanted to understand the limits of that setup. But I'm not going to talk about this today. There will be another stream where I will talk about that. Yeah. So this time I'm going to focus 100% on the simplest possible way to do this. Okay. One thing, don't confuse this challenge with another challenge, with this 1 billion rows challenge, which is how to process 1 billion rows with Java, which, by the way, I recommend you to take a look because it's super nice challenge there. Like you can learn a lot reading how people try to squeeze Java and everything. So anyway.
By the way, Santana, when my bell ring went off, there was someone suggesting maybe it was the ClickHouse lawyers calling.
I mean, maybe. Anyway, the blog post I was showing here, the blog post that I was talking about, you can read everything that I'm going to talk about in this session is here. So if you don't want to watch us like for 1 hour or half an hour, you can just go here and read it. But anyway, so let's start a little bit with a quick intro to ClickHouse and how it works. I'm not going to spend too much time here, but I think that it's important to do a quick refresh on how replica, shards, and everything work at ClickHouse, okay, with ClickHouse. So, I mean, first, ClickHouse is an open source project. It started like in Yandex. They created it because they have to store like a massive amount of clicks, let's say, amounts of events from for their analytics, Yandex Metrica, which is the kind of the Google Analytics for Yandex. Eventually, at some point, ClickHouse, was, I don't know, it was sold or whatever, but anyway, they created a company to own the ClickHouse project, and it's an open source project, of course, still an open source project, and it's an all-up database, and the main point, or the most important point about ClickHouse is that it's pretty fast, and in general, it's pretty easy to set up. If you think about other databases, distributed databases, in general, you need to set up like processing nodes, nodes that manage the whole thing, and so on. In this case, you can start with a simple node, you can push data to that node, and that's it. So you have a laptop, you can run ClickHouse, and that's it. You don't need Docker, or you need anything complex. It just works, which is a pretty interesting thing. Sancha?
Yeah. I was going to say that getting started is as easy really as with any other database, really.
Yeah. So I'm gonna. Can you see it? Yeah. So I'm going to just start up simple. Like this is like a ClickHouse local. ClickHouse local. I think that it runs a server under the hood, but it's kind of a local instance in the same way that you can run like a SQLite or DuckDB or any others. So you can you can run like ClickHouse local and start doing things. So you can create a table, create table A with a in 32. I don't know. I mean, you can do. I'm not really good at typing. That's it. Okay. Good. You can do the typical thing, which is inserting data. So then you can select from B. That's it. So it's a regular database, easy to use. You come from MySQL Postgres. You don't need to learn a lot of things to start with. Okay. So that's basically what ClickHouse is. But usually you don't have just a single node of ClickHouse. You set up a whole cluster with different shards and replicas. And I would like to explain a little bit what a shard and a replica is. So I have this diagram here. In general, shards, when you have data, like imagine that you have like, I don't know, 1 million rows or something like that, you can put that data into different shards. So you can split that data every, I don't know, 100K rows. So you have 10 shards, and you put 100K rows in each shard, right? So in this case, imagine that we have 1 million rows. We have 2 shards, 1 shard and 2 shards, and you can see that there are like many nodes inside. I'm going to talk about that later. So you have 1 million rows. You can put 500,000 here and 500,000 here. That's it. You might decide how to put what, what's the strategy.
How to break it up, and what's the right way to break it up.
So it could be random, which is pretty good because you don't need to make any decision. You just get a bunch of half of them and you send it to one shard and the other half to the other. Or you might split by whatever. For example, in this case, we are going to send telemetry data for cars. So you might decide to split by, I don't know, by license plate or something like that, but the last number of the license plate. I don't know, whatever you decide.
Whatever that helps you ensure that it's going to be divided equally or roughly equally, right?
Yeah. In general, that random is easier for ingest, but bad for reads. And you pick a different strategy, usually harder for ingest and resort, but easier for reads. I'm not going to go into details, but that's a little bit the 101, okay? So inside each shard, there are like nodes, like ClickHouse nodes, the thing that I just showed you in my terminal. So you have different, nodes, and instances, these are replicas.
CPUs running ClickHouse, basically.
Yeah,
so a number of.
Yeah, that's a machine. In this case, there are 6 machines plus this one. I'm going to talk about this one later. So if you have 1 million rows, 500,000 rows goes to this shard, and then each replica has exactly the same amount of data. So when you push data into this shard, into, for example, this replica, the data, you push into this replica, the data is sent to this ClickHouse and this ClickHouse, okay?
So it's going to get a copy of the same data in each of the nodes within each shard, basically.
Yeah. There are like different configurations, of course. You can store the data locally in a local disk here, or you can store this in a cloud storage thing. Like you can use S3, Google Cloud Storage, Azure Blob Storage, whatever it is, but you can do that. We'll talk about that later a little bit in detail because I'm gonna show a little bit the ClickHouse config, but that's how it works. In general, ClickHouse uses Zookeeper to manage the whole cluster. Let's say that we have 3, in this case, 6 replicas, 3 replicas each shard. So the way that ClickHouse, the storage that ClickHouse uses to know where it's to coordinate replicas and everything, and I'm going to talk about that later. But so when you insert something here, this guy is going to push some information into Zookeeper. So these guys here are going to read it somehow, and I'm going to know that there are like some new stuff here, and they are going to go to get the data. So that way they replicate the data. If you are using a 0-copy configuration, the data doesn't need to be copied, but you still need to copy some metadata, okay? We'll talk about that. So this is the 101 about ClickHouse config.
Essentially, Zookeeper makes sure that each instance is aware of all of them, has the same access to the same metadata about the data that it's being stored, essentially. So what has been written and what needs to be replicated, etc., etc.
Yeah, in general, Zookeeper is used for everything. Every single thing that needs to be coordinated goes through Zookeeper when you are talking about replicas. For example, you are creating a table on the cluster. You create the table in one of the replicas. The replica goes here, adds the create table kind of statement into Zookeeper, and the other replicas get from that queue. It's a queue. So they run the create table. We are going to see it, so don't worry about that. So that's a little bit how it works. What we are going to do, the configuration that we are going to do for this specific thing is way simpler, which is I'm gonna do basically, I'm gonna copy paste. Basically, this is what we are going to do, which is we are going to do a little bit of a hack. So we are going to have 50 shards with 1 replica each. So in this case, there are like 2 shards, 3 replicas. In this case, we are going to use 1 one replica, 50 shards. That's a stupid configuration. You should not use that configuration ever, because if one of the shards go down, you lose data, basically. Right. So usually, at least, you should have at least 2 or 3 replicas
per shard.
Anyway,
yeah.
And I'm going to use, and I'm going to use a zookeeper. And you might ask, but you don't need zookeeper if you are using shards, because shards are not the only thing that need coordination in ClickHouse is replicas, the data replication on when you have a cluster with replicas and so on. But if you have shards work in an independent way. They don't know about other shards. So so in this case, I'm going to use zookeeper for other stuff that you will see. David Bonilla is asking 1 proper billion or 1 American billion. I guess that, I mean, I know that Bonilla is European, but yeah, it's an American billion. It's,
one freedom million. 1 freedom billion, you know, one American billion.
Yeah. Okay, so that's a little bit how everything works. I will see this more in detail in the configuration and everything. Okay, so what's the problem that we are actually solving? I mean, what we are going to do to actually ingest 1 billion rows per second. So in this case, what I did is, okay, I guess that Tesla is pushing telemetry data from cars. To be honest, I don't know if that's true or not, but I love telemetry data, so I decided to go with telemetry data because it's like a pretty convenient for this.
And you love cars too, and you love cars too. So
yeah, cars. I mean, Tesla not so much, but cars I love them. Anyway, so basically, if I get this query, that this query here is the one that generates the data. I'm not going to use data that I already generated. I'm going to use queries to generate the data. Why? Because generating 1 billion rows or 10 billion rows or 100 billion rows is a pain in the ass, to be honest. So I decided to use a query to generate the data, which is pretty handy because you can generate as many rows as you want, and that's gonna work. So for example, if I get this query, and I hope, I hate NeoBeam, to be honest. I'm using it because I want to be the cool guy, but to be honest, I'm gonna switch to Beam. Yeah, that's it.
There you go.
Because I don't know what's going on, but it's trying to copy paste. I don't know. It's not copy pasting the whole thing. I guess that I'm doing it wrong. But anyway, I'm gonna run this query. Okay, this query basically generates like a few columns, time, resource. In this case, it's like, okay, maybe the license plate or whatever, scope, which is the telemetry, metric name. In this case, there are like 3 different or 4 different metrics that we are sending. To be honest,
speed and battery and temperature.
It's interesting that, you know, I generated this query with ChatGPT, and it's adding RPM, which is, in general, I don't know if electric engines or electric motors are like you need to take a look at that. But anyway, is there a pretty stupid one, to be honest? But I mean, well, it's not that bad. It's 11K, and then some attributes that I'm not gonna use, but I push I push them because I wanted to make each event a little bit wider. Like I wanted to push more bytes in each event. Because I wanted to test, you know,
with proper data,
you know, everything behaves with more data. But anyway, as you can see, the data is super simple, not really a big thing. So what I'm gonna do, I'm gonna create a table and I'm gonna push this data. That's what I'm gonna do. No, I'm not gonna do like crazy stuff. I'm not gonna do generate data, or push through a Kafka or something like that. I just gonna create a table and run insert into from select. That's what I'm gonna do. And then, but the main problem here, when you try to push 1 billion rows per second, is that you are going to hit. If you want to use just one machine, you are going to hit all the 100 million limits most likely. You are going to hit CPU limits, memory limits, I/O limits. So it doesn't make any sense to do just in one node, of course, you need to scale that with many nodes. So you have 1 million rows, and you have that each node can push 100 million rows a second. You just need 10 nodes, let's say, because in this configuration of ClickHouse, writes scale linearly. Right. You add 100 million different ClickHouse nodes, it's going to scale linearly forever. So and that's a pretty good thing. Of course, that's if you are starting by random. Let's say you don't have like a strategy, just get the data and push the data in a random way. But anyway, I'm gonna make this okay. So this is what I'm gonna do. And where is my Vim? Here. I'm gonna push this here. Let me. Okay, that's it. So that's it. Not really much.
Someone's asking.
Yeah, I think that's, I don't know. It's like 100. I think that is less than 200 bytes. I'm gonna explain a little bit why is that, because I'm cheating a little bit. Of course, I mean, if you are doing something like this, you cheat all the time, right? But because
you look
otherwise,
for the shortcuts.
Yeah, of course. I mean, I'm gonna raise 50 machines. I didn't want to raise 100 or 150 because it's like the problem is exactly the same, and it's not going to add any news. I mean, the number of machines, but to be honest, it's more money that we are going to give to Google. Anyway, so in this case, I'm going to jump into the code straight. So in this case, what I'm gonna show you guys is I'm gonna go here and I'm gonna make this a little bigger. Can you see it?
Yeah, if you make it slightly bigger, just slightly bigger, one more maybe. Yeah, that's great. Yeah, good. That's perfect.
So what I'm gonna do right now is I'm gonna do here. So I'm gonna basically what I'm gonna do is create 50 machines. First, create a zookeeper instance. Okay. Then I'm gonna create 50 ClickHouse machines. I mean, I'm gonna get 50 32 core machines in Google Cloud, and then in each of them, I'm gonna install ClickHouse, like a regular ClickHouse, the ClickHouse that you can use. In our case, for my test, we are using our fork because it has some nice things that the open source version doesn't have. But anyway, for the sake of simplicity, I'm going to use the ClickHouse open source version. So in each of these ClickHouse instances, I'm gonna run ClickHouse, and I'm gonna create a distributed database here.
Yep.
I'm gonna create a table in each machine, and I'm gonna push data, and then I'm gonna query a whole data at the same time. Okay.
At the same time.
That's what I'm gonna do. So how do you do that? So basically, I have a few scripts here. The scripts are pretty simple, as most of them are generated by ChatGPT, because to be honest, I don't know how to use the G Cloud command line tool too much. Actually, I had some scripts like from 2 years ago when we were testing some stuff. I'm reusing them. So they're like if you go here to the start thing, you will see that I'm using like a kind of a super old version of Debian. Someone in Hacker News told me that it's like you are using a super old version. So if you update the Debian version, you most likely you guys are going to get like a push because the kernel is much better. But okay, that's fine. Thank you for that. We'll do it. But anyway, if you take a look at the script, it's quite simple. Not really interesting. What I do is like first I check if there is like a instance called TV zookeeper 000. If not, I'm gonna drop it. Then I'm gonna create the zookeeper instance. And the main interesting thing here is first there is a local SSD that I'm gonna use for caching. I'm gonna use a Debian 11. There are like a few things here. I'm not going to create any network. I'm going to use the default one. And then this is the most important thing, which is I'm gonna use a startup script The startup script, I'm gonna show how it works, but it's gonna basically install ClickHouse, set up the disks, and create the server. And I'm gonna set the config that's needed by ClickHouse to run. I'm gonna show the configuration as well because it's kind of a reduced version of the ClickHouse configuration. And then I set some metadata, like the bucket to use, where to put the data, because we are using cloud storage, and the keeper ID, which is I'm gonna explain this a little bit, which is when you run Zookeeper, different nodes of Zookeeper, you need to assign one ID to each node of Zookeeper. So I'm assigning the keeper ID equals 1. Okay. So if I go to the I'm going to show you the startup script. This is what we run. No, startup. Okay. So this is what we run when we when the machine gets up. The first thing that Google Cloud does is to run this script. That's the first thing. So what I do here is like I create the disks. To be honest, I'm not an expert on Linux, but I just copy paste this from probably the Google documentation, so it's working fine. I create some folders that are needed to store ClickHouse data. I push the config XML that I'm going to show you in a while, the users.xml. I create some folders. I get the binary from ClickHouse.com. I install some stuff that I need. Then I print some stuff to check that everything is working. And depending on the keeper ID, I run a keeper, ClickHouse keeper, as you can see here, for a server. When I, every single time that I said Zookeeper, it's not Zookeeper what I'm using. I'm using Keeper, ClickHouse Keeper, which is a version of Zookeeper.
Reimplementation of Zookeeper, basically.
It's done in C++ with a different protocol and so on. But anyway, the interface is the same. So I'm using it because I don't need to install Java or anything like that. I can just run the same binary. I just need to call it Keeper instead of server. So I run Keeper instead of server. That's why in the previous script, I said Keeper ID equals 1. So I run Keeper. And when I said Keeper ID different than 1, I run ClickHouse server, okay? So it's pretty simple, pretty straightforward. You don't need, in theory, I could remove half of this script and it will run ClickHouse, default ClickHouse server with this. So you don't need to do many things to run a ClickHouse server. I'm going to show you the configuration.
Just as a quick recap. So you install the Debian, you set up the directories in that it's going to then refer to in the configuration, install ClickHouse, and then add it to sort of refer to the Zookeeper. Started as a server with referring to the Zookeeper server, basically, that you've set up, right?
That's it. So this is the ClickHouse configuration that we are using, which I'm going to go through the most interesting parts because in the next stream, we are going to go into details here because there are like a lot of configuration here that you can tweak. In this case, to be honest, you don't need to tweak a lot of things. Basically, what you need to do is, set up the right paths for the logs, as I'm doing here. Can you see it good? That's it. Ports, I leave the default ones, some background and things and so on that I'm going to explain in the next stream. I told where the data is going to be stored. In this case, we need to differentiate between where the metadata is going to be stored and where the data is to be stored. The metadata is stored here in the local disk. The data is going to be stored here in this bucket, okay? In this folder, in this bucket. Of course, you need to, what I'm doing here is like, I'm enabling the Google Cloud Storage has support for S3 protocol. So what I did is enable the S3 protocol. That's why you see S3 on the type. This is the disk configuration. So you set up this, access key, secret key, and then I created a cache disk that I don't think that I'm using, but we'll use it in the following streams, okay? And then once that you have the disks, you set up the policies. In this case, I created just a policy that is like S3 only, because I don't want to store anything locally, any data locally. And then what I do is there are like a few more things that you can set here, not important right now. And then I'm gonna go to the part where I go to the merge tree, and I'm gonna explain what merge tree is. Merge tree is the engine that ClickHouse use. There are like many engines, but the most important one is merge tree. The engine is how the data is handled in the database. So when you push data, depending on the engine of the table, ClickHouse does different things. So in this case, I'm going to use merge tree, which is the most common one. And in this case, as you can see, they're like a storage policy S3 only. That means that every single table that I create, which is a merge tree, is going to use S3 to store the data, okay?
Yeah.
There's like one interesting thing here that we'll talk about that in the following streams, which is zero copy replication. I'm not gonna talk about this, but this is what allows you to have replicas, different replicas, but having
sharing
sharing
the same data.
Yeah, so it does, S3 and GCS, they are already distributed systems, so you don't need to replicate a distributed system, so it doesn't make any sense. So basically, you store the data once, and all of the replicas point to the same data. Okay.
Yeah.
In this case, we're not
using it, but just sort of when you have zero copy replication, it means that you can set up a replica with zero copy. So it'll just needs to be aware of the metadata through Zookeeper, and then then it'll know where to go find the data for the queries and the tables and so on, right?
Kind of. It's not exactly that, but don't worry, we'll explain that in the following stream.
Sounds good.
The last thing that we are going to do is set, when you run Keeper or ClickHouse server, I'm using the same configuration. So in this case, when you run Keeper, ClickHouse with as a Zookeeper is going to use this configuration, and it needs like some Keeper ID, host name, and everything. And if you are a regular instance, you are going to connect to this host. And this host, if you see the startup script, you see that this is the host that I'm creating first. So you can actually go there. So after that, I delete all the instances just in case I left some previous one of this. So in this case, what I'm gonna do is create 50 instances following this TCH pattern, 001, 002, and so on. Exactly the same startup script, the same config and everything. In this case, I'm cheating a little bit because I'm showing you a different config than the one that I'm using, because I don't want to show you some secret keys and everything, but it's the same. And then I'm gonna copy a script that is called run into the Zookeeper instance. You will see why. The reason is because I'm gonna SSH into that machine to run the whole test. So the run script allows me to run queries in all the replicas at the same time. Okay. In all the shards. Okay.
Yeah.
Good. So far we are good.
I think so.
Good. Yeah. So let's run the script. So I'm going to run the start script, and I hope that it doesn't fail. If it fails, we close the stream here, and that's it. I hope it doesn't fail. So again, what this is gonna do is it's going to create the Zookeeper thing. After the Zookeeper thing I'm gonna hide this. Okay. It's going to create the Zookeeper instance, and then after that, it's going to set up the Zookeeper server. Once that is, first is deleting that because I've been doing some tests, and then it's going to delete all of the previous TCH instances, but were removed already, and it's gonna create 50 instances. Okay, it's usually pretty fast. Let's see if now it's fast, but I hope that it is. In general, it's pretty fast. It takes less than a minute to run the whole thing. So
one question, Santana, while this is going on, when you're only setting up one Zookeeper cluster for 50 replicas, 50 shards basically that are going to be writing data like super fast and so on. What is the, how big generally does the keeper or zookeeper instance needs to be in comparison to, or in distribution with, depending on the number of shards or replicas that you have?
Yeah, in general, the first thing is like you need more than one zookeeper node. Otherwise, if that goes down, you're in a pretty bad situation. You need at least 3. I think that they recommend like to have 5. To have like a good quorum and everything, because zookeeper is like a pretty solid database in general. You can see the Jepsen report on zookeeper, on the Java zookeeper. I don't know if they run the Jepsen on ClickHouse keeper. I think that they do. They did it, but anyway, it's a pretty solid database. People usually hate it because, of course, when it fails big time. But in general, it's a pretty solid piece of software, and some people hate Java, sorry. So, and that's why people usually hate zookeeper. But in general, it's a pretty good piece of software. Anyway, with that said, let me see that. And about the size, it depends on the reads and independent writes. You have a lot of writes and a lot of reads. You need more servers. In general, in this case, as we are not writing to zookeeper, we could use a 1-core machine. But in the next stream that we are going to be writing to 50 machines, 50 replicas, and they need to coordinate, you need at least a 16-core machine for the writes. That's what and still it suffers a little bit during the test. Anyway, let's see if looks like I was saying no, this doesn't fail, whatever. But looks is taking time. It's taking time. Let me check if what's going on, because I had some script here which is bash status. Let's see, they are running. No, it looks like they are running. Okay, yeah. Okay, that's good. Anyway, okay, not failed once. Okay, that's good.
Awesome. Boom.
Good. So in theory, we have 50 of these and one of these. Okay. So what I'm gonna do, I'm gonna SSH into this machine, and for that I created a script called Vamos. That SSH into the instance. I usually do scripts for everything with names that I remember, because otherwise I need to go and search for the command and everything. So in theory, this will be a ClickHouse. Is ClickHouse version? Yeah, a ClickHouse here. So the next thing that we're gonna do is create the database. And you might guess, what the fuck are you talking about? So in every single database, you create a database to store tables. So it's kind of a isolation and everything. Every single database has that. So in this case, I'm going to create the database. And in this case, I'm going to create a database in all of the replicas. I need to create in all of them, because as I said, they are totally isolated. They don't know about the other ones. So what I need to do is to run this command, which is going to go, this run command is going to go through all the 50 replicas, and it's going to run the command in all of them. So if I go here, and I'm going to give run permissions to run. If you check run, the script is like a pretty stupid one. It's a for loop. To be honest, I bytecode it. So I don't know what is inside, but I know that it's like a for loop because I had to fix it. But this is a little bit what it is, okay? So if I run the command, which is, I know, well, okay.
Everything had worked so well.
Don't worry. It doesn't matter if some of them are failing. I don't care. Anyway.
So basically, go ahead. Go ahead and explain what you did. What just happened? Yeah.
It's like I created a database called Flock in every single replica. But the main thing, and this is important, I created it with replicated. That means that this database is replicated. So every single thing that I do in that database is going to be replicated to all of the instances, okay? So, which is super handy, because I don't need to create, again, 50 different because I just want to create a table and that's it.
Yeah. So now you just create a table and it will automatically replicate that command across all the charts, basically.
Yeah, that's it. So I tried again to run the command to see if it, create in the databases that we didn't manage to create. But anyway, it failed because already exists. Don't worry, that's fine.
Yeah.
So the next step I'm gonna do is I'm gonna create the table. And to create the table, what I'm gonna do is I'm gonna connect to one of these replicas. Okay. So in this case, I'm gonna do this. I could run it, but I'm gonna connect directly. So I run ClickHouse client host the first machine. Okay.
Yep.
So we are connected here. You see it well? Yeah.
Yeah. Yeah.
So the next thing I'm gonna create is a table. I'm gonna stop here a little bit to explain a little bit about the table. So in this case, I created the table inside the Flock database. As you can see, I'm gonna make this a little bit bigger. Inside the Flock database, because again, as it's a replicated database, so everything that I create there is going to be replicated in all the instances, okay? I'm going to call it this name, and I'm going to use time 64, resource, low cardinality, scope, metric, what we saw in the query that I ran before, okay? The main important point, and that's why I said I'm cheating a little bit, is because I'm using low cardinality in all of them. It's not cheating, it's the right choice, but instead of storing the actual string, low cardinality stores just an integer, which is, you can actually, instead of writing like, I don't know, for each string, I don't know, 10 bytes or 20 bytes or 30 bytes, you are storing 4 or 8 bytes, I don't remember. But anyway, that's way less information. It's going to compress much better. It's a fixed data type, so it's faster to access. So in general, low cardinality is a good data type. You should use it if you can. But just to let you know that I'm using it, I'm kind of faking it a little bit. But I mean, it's cheating a little bit, but yeah.
No, it's what you would do when you have like so you're not really cheating. That's what it's there for, it's what you would use with when you have low cardinality.
Whoa, I didn't realize that. Whoa, look at this. Look at, whoa, I mean, they are coloring the whole thing so you can match exactly when it starts and where it ends. Do you see? Yeah, I never saw something like that. I mean, anyway, I'm gonna create what I did. Okay, sorry guys, I run the whole thing. I copy paste the whole thing. I just need the create table. Okay, I'm gonna run it. It's running as I said.
Yep.
As it's a replicated database, it runs in every single replica.
Yep.
Sorry. This is kind of an interesting thing because I said I'm using shards, and now I'm talking about replicas. That I'm cheating a little bit because I created in every single shard the same database which is replicated, which that doesn't make any sense. So I don't need to run
the same command everywhere.
So that's why. And it's useful because if I go here and I go here to the system clusters table, sorry, I can see that there's like a flock. Sorry, I'm going to make it a little bit smaller so you can see it. No, you're not going to see it anyway. So you can see there are like 50 in the flock cluster, and they call it replicas. But actually, they are kind of replicas. But the reality is, as I created the table as a merge tree, this data is not going to be replicated. So if you want the data to be replicated, this should be replicated merge tree. It's a different kind of engine, and I'm gonna talk about it in the following. It should be something like this, and there are like some parameters here that you need to allocate. Okay, but for the moment, I'm gonna stick to that. I see that there is a question about what happens if you have high cardinality. To be honest, we tested this with tens of million different values, and it worked well. ClickHouse recommends no more than 10K different values.
For low cardinality, right?
Yeah, for the low cardinality, but we push into more than 10, 20 million different values, and it worked pretty well. Maybe it's because we are sorting the table by one of the columns. So and I'm gonna go into details here, as the kind of the mapping for the integer to the string is stored in its part. Maybe I think it's part or granule, but anyway, maybe there were not so many different feeds per part. So the reality is that maybe there are like not so many different values in reality, even if you have if the whole data set is like maybe 100 million different values. But anyway, I didn't test it, but maybe it worked. Actually, you check how the Parquet format works. By default, it uses low cardinality for every field, and nobody is complaining about that. So I guess that's not a major stuff. Anyway, I guess that it depends on the implementation and everything. I'm not gonna stop too much on this. Okay, good. So I already have the. I don't know what's asking here. Anyway, the next thing I'm gonna do is I'm gonna exit here because I already have.
Yeah, you have the table created in every instance. We haven't pushed any data yet, and they don't yet know they're shards, right?
No, they are just machines. So we already the hotel table is in its
each instance.
Machine. Yeah. So what I'm gonna do now is I'm gonna run a script from here that is gonna execute an insert in its sum. Okay, and you might ask, but you created a replicated kind of database to do it, but the replicated thing is useful for create tables, drops, and so on. Selects and everything, you cannot run them on cluster. I mean, that's not true because I'm gonna do later, but inserts I need to run in each different, in every different replica. And that's that's what I'm gonna do. So I'm gonna copy paste this, and basically this is the query that I had before that generate fake data.
Yeah.
And of course, this is cheating a lot because when you are pushing data from a different service, because in theory you should have here like a service, an ingestion service, maybe Kafka or whatever that, plus something that actually pushes data into ClickHouse. Of course, there is the networking, there's like encoding and everything. And here I'm running this inside the database, which is like cheating a little bit. Okay. So
one question: how many rows are you going to insert right now?
I'm gonna insert 1 billion rows each shard. So in total, it's going to be 50 billion rows in total. And I could ingest less, but it's fine. While it ingests,
well, that's happening because this will be the most watched moment. I'm going to do some product placement right now by drinking from my tiny bird.
No, but anyway, there are like a few important things here, which is I'm running the insert into table select to generate the fake data, but I'm setting some attributes here. I'm going to talk about them in the following stream because this is quite important. But in general, long story short, this block size rows means that each insert is going to have 20 million rows, because in general, when you insert data into ClickHouse, you don't you insert like parts. So each insert is at least one part. So if you don't set up this value, if you insert a lot of data, it's going to generate a lot of different small parts, and that's a huge problem because if you have many parts, you have like a lot of things to manage, and you keep the too many parts problem that probably everyone here listening to this suffered in the past. Insert block size bytes is basically a way to say, okay, you don't reach this, you reach this one, so write that the part as 1 gigabyte in this case, okay? And I set some insert threads, so this is super fast, okay? So it looks like it failed to execute, but to be honest, I don't care if it fail or not, because the data in theory is in. So what I'm gonna do is I'm gonna just go to, so the data, all these hotel tables, they already have 1 billion each, okay? So what I'm gonna do next is actually check that we push more than 1 billion rows per second. So I have some SQL here, some SQL queries here. And in order to know if we hit the 1 billion rows per second, what I did is, what I do is using part log. So as I said, if we insert, generate many parts, those parts are recorded in this log, in this table. So we can go and check how many new parts and the total amount of rows. I'm grouping by intervals of 5 seconds. And I, of course, divide them by 5 here. So what I'm going to do is run this query. No, sorry. I'm going to connect to this
one
machine.
of the instance.
Yeah, I'm going to make this bigger. And I'm going to run this. This probably is going to fail. No, it's not going to fail. Okay. So as you can see, there are like a few. We started like with 375 million rows, and then it went to 2 billion, 5 billion, 1 billion, 10 million. So we managed to sustain more than 1 billion row for 15 seconds, which is a pretty good thing. Of course, it's a pretty stupid test, but we managed to get the number. That's what we wanted, and that's it. So that's a little bit how easy is to do it. And if we wanted, for example, to just query the data in the table to understand how much data we have in total, we can do select count from, and this is where I'm gonna cheat. I'm gonna say, okay, as I said, all the shards as replicas, I can say, okay, I can use this function, which is cluster of replicas, that is gonna run a query in all the replicas of the cluster. So as shards, as I tell the system that those shards are replicas, I can query the table. So the query is this. Yeah, that's it. Yeah. So it's 49 billion. It's not 50 because some inserts failed. I don't know why. This is the first time I run this script that failed to insert, but it doesn't matter. If we run, of course, of course. I mean, if you show, for example, let me run a more interesting query. We can do a count from cluster replicas group by all. You see that it's going to take a little bit more time. Not that much. It's good. Whoa. We process 68 billion rows per second, which is pretty good.
I mean, you have a lot of so because this query is basically what's happening is each ClickHouse is counting separately on their shard, and then the result of that is being added together and so on. And we have like 32 CPUs times 50, so that's a lot of processing power.
That's it. So this is a little bit the whole thing. If we run an analysis on because of course there are like a few things that are happening here, which is once that you insert the data, this is not the end of the process. After you insert the data, there's like another process that starts, which is called the merge. The merge process is what get all of those parts and combine them into bigger ones. Because imagine that you have 100 million different parts. You want to query that data, you need to go over 100 million parts to get the data to calculate the actual query, right? And that's super slow. So you need to compact that so you have like bigger and fewer parts so you can run the SQL query faster. It happens in every single system that use the merge tree kind of algorithm. This not called it's LSMT, whatever. I forgot the name, but anyway, there's like an algorithm that is used by many databases. Most of them right now are using them. I'm talking about analytical databases and some key value as well. So they use that algorithm to compact everything. And for example, if you use Iceberg, you have that compaction process as well in order to speed up queries. But it's exactly the same. But in this case, as you are pushing in real time, that process needs to be super fast. Otherwise, you start to accumulate a lot of parts, and the server at some point stop ingesting data. Okay, so if we check, for example, how the table looks like now. So I'm gonna run this thing with the right table, which is this one. And what this is showing is an histogram of the part size. So in this case, this table has 329 parts. And if you check, there are plenty of them that are under 500 megabytes. Yeah, and in theory, we should try to go up here, and we should try to have like as many big parts as possible, because we will have less and so on. Of course, you can configure that in the config.xml and so on. So that's a little bit. And if we check, for example, we want to check, for example, the merge processes that are happening. I have this query, and you can check. I will share everything here, but basically what I'm querying is the part log, and basically I'm aggregating per 5 seconds. I'm showing how many actual parts are being merged per 5 seconds. So at the beginning, it's like a lot of parts, and then as they get bigger, there are fewer of them. But we have been like running the experiment for a while, and still running, and it's gonna be running for probably hours. And this is a problem, and we'll talk about that in the next stream. Okay. And that's a little bit it. I don't know if there are like any questions about this. Otherwise, I can explain a little bit the problems, which some of them I already explained them. And
I was going to say, like, you know, we've you've gone ahead and inserted so 50 billion rows, or 49, I think. But you know, and then stopped. What would we start to see if you would keep that going for, you know, 10 minutes, 15 minutes, you know?
Yeah, in general, what will happen is that at the beginning, it will go fast and well, but then the merge process kicks in, start merging parts. But if the merge process is not merging parts at the right pace, parts will start to accumulate. So when you reach a number of parts that you can configure, you start
failing the inserts.
It starts to say too many parts, and then all your ingestion pipeline is broken, and so on. And that's, if you use ClickHouse, that's going to happen to you 100%. I mean, no way that you are not going to suffer that 100%. And that's why usually people put something before that, some kind of Kafka or any ingestion pipeline that allows you to not just back pressure in case of a problem like that, but there are like other problems like memory problems. There are like, for example, because in general, if you are just writing data, you can more or less calculate how many cores you need. But of course, you are not just inserting data, you are actually sending queries. So you're running a massive query that is using a lot of memory. You might fail because you don't have enough memory. So you need to wait a little bit until you have enough memory to push that or add more shards or replicas or whatever. So that's a little bit the pain. And if you take a look at the Tesla presentation, they talk a little bit about how they do it, and not in huge detail, to be honest, but I more or less created what I think that they are doing, which is this is like a pretty I'm gonna copy this into Beam. Okay, I'm gonna make a little bit smaller so we see it. So basically, this is what I think that they have in reality, which is I think that they have some rights. They have a Kafka, which is Red Panda in this case. I know because that's public information, not because I'm a friend of any CEO. They are probably, and I don't know I don't know.
How many?
Most likely they are sharding by some key, and they probably have a lot of partitions. They probably have They do have something which is real-time ETL, some process that actually gets the data from Kafka and push that into ClickHouse. And probably they have like many shards with many replicas, and probably they have a zookeeper cluster per shard. Not they don't have like a massive ClickHouse cluster. They probably have different ClickHouse cluster, zookeeper clusters in order to scale that up in the right way. And then probably for reads, they have a load balancer, and the load balancer probably picks the right shard to, for example, you want data from a specific car, maybe if this is sharded by license plate, probably you don't need to go to all of the replicas. All of the shards. You might need to just go to one. So this probably load balancer, and I'm totally guessing, I don't know if that's true, but it's likely that something like this is happening. This load balancer get the actual SQL query and goes to the right shard and to the right replica, because of course some replicas could be getting data, some others could be actually serving reads. So that's a little bit the thing. Okay.
Yeah, makes a lot of sense.
Yeah, and that's what I think. That's in general the whole thing. As you see, it's like pretty easy. Like you set up 50 machines, you insert in parallel, as they are totally independent. You don't need to worry about. You can push if you need like you need to ingest 2 billion rows per second. You have 50 machines more, and that's it. It works. The problem is when you need to read, as we saw, it needs to query all the in this case all the shards. Okay, I'm using the replica thing, but that's a trick. But in this case, you just with 50, to be honest, it's pretty fast. So I don't think that 50 is a problem. Probably, and I read something about that if you hit like a 100 or something like that, you need to start sharding and having different levels of sharding and so on. But to be honest, we don't use sharding. We just use replication at Tinyverse. So we are not really experts on sharding because in general with replicas, you can do a lot of things. And that's what I'm going to show you in the next stream, which is going to be way more technical, because we are going to go into what's happening when you push data into a replica, how that's replicated, the problems that you have with the replication queue, and everything. And that's a little bit it. I probably left 100 things that I forgot, but that's it. In the blog post is way better explained that I did in the stream, most likely. But anyway, that's it.
Yeah. Before you go, Santana, can you open a browser quickly?
Yeah, what do you want?
Go to tinybear.co/builds. So I just want to let people know /builds. I just want to let people know that we're doing these sessions on a regular basis now, and we have a YouTube channel where we leave them all. That is not the Tinybear YouTube channel; it's just a separate channel. So we have the goal is to do these type of sessions where we just talk about things that are useful for developers and engineers, such as your talk today. But we'll be, for instance, the next one we'll be talking about open telemetry and how to instrument an application and so on. So yeah, check it out. And if you enjoyed the talk, subscribe to the YouTube channel and keep an eye on us. And you can watch them live, or you can watch them once they've been, whenever you want. And there you go. Tbird.co builds is how you find it. Thank you very much, Santana, for setting this up. Now, please don't forget to turn off all the machines. Our gross margin is getting worse by the minute. So please,
ask him to do that. Look magic.
Awesome. Stop. I like it. Vamos and stop. You couldn't forget.
That's it.
Awesome, man. That was a great session. Thank you very much. And see you everybody in the next one.
Bye, everybody.